Good morning all of you. In this class we are discuss about the D flip-flop. That is one of the application of your flip-flops. In our last video we are discuss about the SR flip-flop, that is also called as initial flip-flop. That SR stands for set and reset flip-flop. Basically in our last video we discuss about the SR flip-flop logic circuit, their logic symbol, their truth table and the equation also. According to the truth table of your SR flip-flop, we have discussed that we are having with the four conditions, that is 0 0, 0 1, 1 0 and 1 1. So for that for two input, for that 0 0 basically there is a no change. For 0 1 there is a reset condition. For 1 0 there is a set condition, and for 1 1 that is indeterminate condition. So basically that 1 1 is not in use, practically this is not in use and not possible also. So that's why it is indeterminate condition. When we are use that SR flip-flop and that circuit, SR flip-flop's logic circuit, so this 1 1 condition is not in use, and so that's why the in a continuous in a cycle there this waste of this particular 1 1 cycle, this 1 1 is not in use. So from overcome from this condition we are having with a D flip-flop. So this D flip-flop is basically a modification to SR flip-flop, and here we use in this logic circuit, that is what one of the NOT gate in this logic circuit. So we will discuss here the logic circuit also. So this is one of the application of your what we can say that sequential circuit. Basically this flip-flop is one of the application of sequential circuit, and of the types of flip-flop is what your D flip-flop. So people is also called as that D flip-flop is what data flip-flop. This is also called as delay flip-flop also. Sometimes it is called as a delay flip-flop, and this is what data latch also. So we'll discuss these terms in this video. Okay. So today I will discuss about these logic circuits of this D flip-flop. This diagram, this logic diagram is as same as your SR flip-flop. In this case here, this is what your input to this S and R flip-flop. Here we use the NAND gate, basically this input to this NAND gate and one of the clock pulse. This clock pulse plays a very important role in this D flip-flop. Here as clock pulse is 1, then you will get the proper output, or we can say that your required output. So here this clock pulse always should be 1. If this clock pulse is going to be 0, then your circuit is nothing but as no change condition. This circuit is going to be no change condition. So here that S and R we are having with inputs. This is what your one of the NAND gate, as we are discussing our SR flip-flop. Next output to this S to our next NAND, this latch circuit, we are use this latch circuit, and this is what your present state, basically this present state, that is Qn, and the output we are required output, that is what Qn plus 1. So logic to this, that is Qn plus 1 bar. Yes. So this is our required output. This is called as your next state, and this is called as your present state. So next state is basically your present input plus your present state is called as your present is called as your next state. So here this, as already I told you, this is what your clock pulse we are used, and this is what your D. So this D input is as we can say that is applied to one of the plain input is what you are applied to what S, that is one of the input from SR. So this S and the NOT gate is by using inverter we are applying to your R. So this you can say that this S is equals to your D and R. Yes, D and R, and your R is equals to NOT of D. That is inverter. That by using inverter we can say that NOT of D is equals to your R. So by means of this we are having with this logic symbol. So this logic symbol shows that this D flip-flop having with single input, basically as our previous condition, that is SR flip-flop having with the two input, and in this D flip-flop is only single input as D. So here the D input and the clock pulse. So here we are having with a single clock pulse, and the output as Q and Q bar. That is the complement of our output. So basically this is what your Qn plus 1. So as truth table we are having with that truth table shows that the D as a single input and the Qn as a present state, and the Qn plus 1 is your next state. So here as a Qn, as we will know that the Qn is don't care condition, because we don't know the value because of this Qn, whatever it may be, that Qn and either 0 or 1 also. So here as we can start our cases, that equation to find the value of Qn plus 1 by using this truth table or by using this logic circuit. So how it should be? So we have start with your case number 1. So here as first condition, if the value of this is going to be 0, yes. So here the two input, basically here the two inputs, we can say that D is equals to, as SR having the two inputs, so that's why it is 0 0 0 1 1 0 and 1 1, but this having the single input, so the condition either 0 or 1, we can say that 0 or 1, and the Qn, as we people know that don't know the value of Qn. So this is what your input side, that is D, and the Qn, that is present state. This is what your present input, that is 0, and the present state as your don't care. For your 1 also, that is don't care. So we have to find out the value of your Qn plus 1. So how it should be? So for D is equals to 0. For D is equals to 0. So what should be? That is Qn plus 1. Basically, this Qn plus 1 is our required output, or we can say that next state. Yes, next state. Whether it is Qn is your output, but this is our present state. This is not our required output. That next state is what your required output, that is Qn plus 1. So that's why it is called as the next state. So Qn plus 1 is equals to, so here we are having with this Qn plus 1. So if the value of D is nothing but 0, so here what 0 applied. So change to this, in here we are applied the 1. That clock pulse is going to be 1, as I already told you. So 0 1, that is AND gate. NAND gate is nothing but here 0, and complement to this, that is 1. Complement to this is what your 1. So this is what your 1, and input to this Qn plus 1, that is 1 and Qn bar. So this 1 into Qn bar and this complement, so that's why it is what your whole bar. So the value we are having with this 1 into Qn, that is 1 into Qn, that is Qn bar whole bar. So that is going to be your Qn. So the value here we are having with the Qn. When we are having with this unknown value, that Qn plus 1, Qn plus, we have find out the value of Qn plus 1, but when we are getting this unknown value, we have to go for the complement of this Qn plus 1. So again we have to just find out the value of this complement, that is Qn plus 1 bar. So here the value is for this is what your 0 into Qn whole bar. So this value is for 0 and the Qn, but here again for this Qn bar we can say that. So here the value is nothing but 0 into Qn bar, that is what your 0 bar, and that is what 1. Yes. So with reference to your Qn plus 1, so with reference to your this, we can say that your value is going to be is equals to 0. So that's why Qn plus 1 for D is equals to 0. Your Qn plus 1 is equals to 0, and this is what your reset condition. So this is what your reset condition in a D flip-flop. So this is what your reset condition. Next, you have to just find out the value of your D is equals to 1. So when D is equals to 1, so the changes in this is what D is equals to 1. This clock pulse is 1. So 1 into 1, we will know that 1, but here the complement, so this NAND gate 1 into 1 is what? 0. So again we have to just find out the value for this Qn plus 1 is equals to, so this Qn plus 1 is equals to your 0, 0 into Qn bar whole bar, 0 into Qn bar whole bar. So the value we are having with this 0 into anything is what? 0, and the bar, so this is what your 1. So the value for Qn plus 1, as Qn plus 1 is equals to, when we are applying the 0 1, so this is what your we can say that 1. So this Qn plus 1 is equals to 1. So this condition we can say that set condition. So in this way we can find out the value of this Qn plus 1, that is next state. For D is equals to 0, it is what? 0, and for D is equals to 1, it is what? 1. So by using this truth table, we can directly say that your Qn plus 1 is equals to D. Basically by using K-map also we can find out the value of this. By using K-map also we can find out the value of this equation. But here it is very clear that 0 1, it is what next state, and the input are same. So that's why it is what your Qn plus 1 is equals to D. So this is what the equation for your D flip-flop. So this Qn plus 1 is equals to D. So in this video we are discuss about the logic circuit of your D flip-flop. Next, what logic symbol. Next, how to find out the value of Qn plus 1 by using this logic circuit. Next, the equation of this D flip-flop. So next video we will discuss about the JK flip-flop, master JK flip-flop, and the T flip-flop. Thank you.